Okay, in question 1 of tutorial 11, we're going to look at monetary policy. But before we look at monetary policy, we have to look at what money is. So we're going to do that. Okay, so in a barter system, in this barter economy, there are 14 goods. And when you have 14 goods in a barter economy, you need this combinatorics, number of combinations equation or formula. And N here is the number of goods, right? And so in a barter economy, you usually trade one good for another. So we have 2 down here because we're assuming that in each trade, uh, there's one good exchanged for another good. But the number 14 is the number, the capital N here. So we plug in 14, and then 14 minus 1 is 13. 14 divided by 2 is 7. So 7 times 13 is 91. So in a 14 good barter economy, you'll need 91 prices. If money is introduced into the economy, there will be just 14 prices. So this alone improves the efficiency of transactions in an economy, the introduction of money. And money does not have to be introduced by government. Money actually arose just out of convenience, right? Now, later on, governments took over the money, but money initially just arose out of the need for increased efficiency of these transactions, right? Okay, so which of the following is not true? Let me pull up my pen here. I got my little epic pen here. Oh, I got to type it, I guess. Okay, so money is a store of value. Yep, that you need that for money. Money can be a precious metal. It doesn't have to be, but it can. Money should be widely accepted. Yeah. Money must be made of paper. Yeah, it doesn't necessarily have to be because it could be, a precious metal. Money should be easy to carry it, right? If it's not easy to carry, people won't hold it as money. It has to be durable, right? If it falls apart, when you put it in your wallet, people aren't going to want to keep money because it's falling apart, right? You won't be able to use it in the future. Imagine you put a dollar bill in your pocket, and when you reach for it to buy a soda, there's nothing left but a bunch of dust, right? So it has to be durable. That's the problem with cigarettes in prisons, right? You can smoke the cigarette and you no longer have the money. Money should be difficult to counterfeit, yep. Money is a unit of account, yeah, because everything in the United States is denominated in dollars, right? So money is a unit of account. Now, it also has to have a double coincidence of wants. And that's where if I have dollars and I want a TV, right? I hold dollars because I know that those dollars can buy me a TV. The salesperson or the owner of the company that's selling you the TV, they want to hold dollars too. They're willing to accept the dollars in exchange for the TV because then they can use those dollars to buy something they want, like a Big Mac or a burrito from Del Taco, right? So the answer here must be money must be made of paper. It doesn't have to be made of paper, right? And we have coins that suggest that that one is not true, right? Okay, so down here we have this central bank from the fictional country Croatia. It set its reserve requirement at 10%. So it set its reserve requirement at 10% here. Now we need to complete the T account down here. So what this 10% means is you got your demand deposits here, right? If the reserve requirement is 10% or 0.1, then this particular bank has to hold 10% of these demand deposits on reserve. And 10% of 50,000 is 5,000. Whoops. 5,000, right? So 10% of 50,000 is 5,000. So this is money the bank has but cannot lend out by law, right? And then on the right-hand side, the 50,000 plus 0 is 50,000. On the left-hand side, this number, this number, this number, and that number all have to add up to 50,000 because the assets have to equal the capital and liability, right? So the way we get this number here is we add 5,000 to 18,000 to 12,000 to 10,000, subtract that total from 50,000, and we get 5,000. And we can double check that this works, right? The left equals the right. This is 10,000, 28,000. Actually, this is 30,000 here, right? 30,000 plus 10,000 is 40,000, plus another 10,000 is 50,000. So it all balances out. Okay, before we move on, I got to erase that. We have to understand how money is created through bank lending. Now, in the tutorial, we don't have this particular question showing up, but it does show up in the homework, right? So in this situation, the Fed buys $100 million worth of First National Treasury bonds. And the reserve requirement is 10%. So what happens here is when the Fed, our central bank, buys $100 million worth of First National Treasury bonds, that means this First National, so instead of lending the money to Treasury through Treasury bonds it holds, it now has $100 million that it can lend out to consumers or businesses, right? So this $100 from the Fed means instead of making loans to Treasury by holding Treasury bonds, it can make $100 million in loans to consumers and businesses, right? So this allows the loan amount to go up by $100 million for First National Bank. Now, First National Bank makes a loan of $100 million, right? Maybe they make that loan to, say, Apple Corporation, right? As soon as that loan is made to Apple Corporation, Apple deposits that money in their checking account at Bank A, right? Now, because Bank A's checkable deposits have increased by $100 million, Bank A is required by law to hold 10%, right? It's required by law to hold 10%, right? Required to hold 10%. So 10% of this $100 million increase in its checkable accounts means that it has to hold $10 million in reserve. It can't lend that out, but it can lend the rest of it out, right? So when it lends the rest of it out, maybe it makes a loan of $90 million to General Motors, right? General Motors, as soon as it signs the loan paperwork and the loan is funded, General Motors then has $90 million in its checking account at, say, Bank B, right? Now, as soon as that $90 million is deposited in Bank B by General Motors getting this loan, Bank B can lend out 90%, right? Because 10% of this 90 million must be held in reserve. So the difference between 90 and 9 million is 81 million. So Bank B can make a loan of 81 million, right? Because it has to hold 9 of the 90 million in reserve or on reserve, right? Now, when Bank B makes this loan of $81 million, the company or the person that gets $81 million, when that loan is funded, that money is put into that person's bank account, and maybe that bank is Bank C, right? So it gets deposited electronically, perhaps, into Bank C, right? Into some business's checking account at Bank C. Now, when that deposit is made, Bank C can lend out or has to keep $8.1 million of it on reserve. It can lend the rest of it out, right? So 90% of 81 is 72.9, right? So it can lend out 90% of the 81 million. Now, does it lend out all 90%? No, it doesn't lend it out. Usually, it doesn't lend it out all of it, right? Okay, so now Bank C is going to make a loan of $72.9 million. When that loan is lent out to somebody, that somebody or something has that money deposited into its checking account in Bank D. Bank D can then keep, it has to keep $7.29 million on reserve. It can't lend out 7.29 by law, but it can lend out the difference, right? Or 90% of 72.9, which is 65.61. Now this continues into infinity right here, and it continues into infinity. And it just so happens that when you add up this column, it will sum to 1,000 million or $1 billion, right? When we sum this column here, it'll add up to $100 million. And this column here will add up to 1,000 million or 1 billion. Okay? So this total here is the change in reserves after all this bank lending, all this lending money into existence occurs. The change in reserves is 100 million. Notice that is the amount of the $100 million open market purchase that the Fed did up here, right? It did a $100 million open market purchase up here. So this $100 million equals that, right? This is the change in deposits, right? This is the change in deposits. So to go from 100 million to 1,000 million, you have to multiply the 100 million by 10. So this 10 here is the multiplier. To get this multiplier of 10, all you do is you take the reserve requirement ratio here of 10% and you divide it into 1. So you calculate 1 divided by 10%. And that right there is the money multiplier, right? 1 divided by 10% is 10, right? If you don't believe me, we can put it into Desmos. 1 divided by 10%, well, 0.10 is 10, right? So 1 divided by 10% is 10. If the reserve requirement was 20%, the multiplier would be 5. If the reserve requirement was 5%, the multiplier would be 20. So you just divide the reserve requirement ratio into 1 to get the multiplier. Okay? Okay, so moving on into our tutorial. We have the quantity of money up here, $1,800 billion. Actually, these should be the same. Trillion, I got a mistake here. This should be billion and billion or trillion and trillion. So 1,800 billion. I'll fix that. I'll edit that out. So our money demand equation is this one right here. The interest rate equals 15.75 minus this slope times M. That's our money demand equation. This right here is our money supply equation. Ignore the typo on the units here. But our money supply here is a vertical line at 1,800, whatever, billion, trillion. Okay? And then to find the equilibrium interest rate, so our equilibrium quantity is the 1,800 because it's just the vertical line, right, independent of interest rates. To find our equilibrium interest rate, we've got to plug the 1,800 into the demand curve. And we do that right here, 1,800 times 0.00625, subtract that product from 15.75, gives 4.5. So this quantity here is the equilibrium quantity, and you plug that 1800 into the demand curve, and you get 4.5. So that's our initial equilibrium. Okay, then we have our aggregate demand model over here with aggregate supply, both in the short run and in the long run. This is our aggregate demand model here. This right here is aggregate demand. This is our short and aggregate supply curve. And this right here is our vertical long run aggregate supply curve. It is at potential GDP equal to $15 trillion. Okay. To find the equilibrium, you can set the demand curve equal to the supply curve, which I did right here, right? You do a little arithmetic and you get 14. You can also do it in Desmos. P equal to 40 minus y and minus 2 plus 2y. Oh, I forgot the P equal. Okay. So I got my aggregate demand curve here. I got my aggregate supply curve here. And the intersection is at a GDP of 14 trillion and a price level at 26, right? So GDP at 14, and then you plug the 14 in and you get 26 and 26, right? Okay, so that's how you can calculate the equilibrium. You can either use algebra or you can use Desmos. Okay, now the economy, if you notice the economy is at this black dot. It's to the left of long run aggregate supply. So GDP is less than what it should be, which means unemployment is high. And when unemployment is high, we're in a recessionary gap, right? In a recessionary gap. Okay, and notice I give you the GDP level here and the price level here, so you didn't have to even calculate it in this problem. Now, the Caucasian Central Bank is going to conduct an open market purchase. The way you remember purchase is the economy needs to be powered up, right? The economy needs to be powered up. So P, open market purchase, open market purchase to power up the economy. Open market purchase, power up the economy, because we were in a recessionary gap. That's how you can remember that. So the Fed's going to do, or the central bank's going to do an open market purchase, right? And it's going to do an open market purchase of $100 billion, right? $100 billion. Okay. And then we're going to assume the money multiplier is 4, right? So what do you do with the multiplier? So we're going to multiply the multiplier of 4, by the change in reserves, 100, right? To get the increase in checkable deposits, which is $400 billion. And we're going to add that to the old money supply, right? And that gives us a new money supply of 2200 billion, right? 2200 billion, right? So 1800 plus 400 is 2200 billion. And so the money supply moves from black to red, right? Which lowers the interest rate. To find the new lower interest rate, you take this 2200, you plug it into the money demand equation, which starts with I, right? So this is the quantity of money here. The new quantity of money is 2,200 billion. You multiply that by the slope and subtract that from 15.75, and you get an interest rate of, a new interest rate of 2 percentage points. Okay, so the new interest rate is 2 percentage points. So the new equilibrium interest rate is 2%. Now, assuming the monetary policy works as intended, it closes this gap. And inflation expectations are constant. The real rate of interest is going to fall by this amount, and that's 2.5 percentage points, right? 4.5 minus 2 is 2.5. Now, this increases investment expenditures, right? And increases exports. Both of those cause the aggregate demand curve to shift outward. So we have a higher intercept, right? Remember, the intercept includes things like investment expenditures, exports, taxes, government spending, wealth, expected future income, the real rate of interest, all that. So the new aggregate demand curve is going to be pushed outward, right? So it's going to increase aggregate demand. And it increases to the point where it crosses short-run aggregate supply and long-run aggregate supply at the same point. Okay? So they all cross the red curve, the upward sloping short-run aggregate supply curve, and the vertical long-run aggregate supply curve all intersect this point. And remember, at this point, GDP is 15, right? So we're going to plug 15 into our aggregate demand equation, and we're going to get a price level equal to 28. All right? So GDP, the new GDP is 15. The new price level is 28. And that means, and I give it to you right here, right? The real GDP is 15 trillion. The price level is 28. We just found that out. The new gap is 0 because, remember, potential GDP is 15 and new GDP is 15. And 15 minus 15 is 0, right? So monetary policy caused real GDP to rise from 14 to 15, increase. It caused the price level to increase as well, right? So we have inflation, according to the model. And the unemployment rate went from being really, really high at the black dot to being just right at the red dot. At the red dot, unemployment is equal to the natural unemployment rate. So the unemployment rate decreased, or decreases, right? And that's question 1.